This is the continuation of lecture number 1. In the previous video, we looked at some right angle triangles. In today's lecture, we're going to look at triangles that are not 90 degrees, that are not right angle triangles. So I'm just going to draw a triangle here that is not 90 degrees. Okay, so this is obviously not 90 degrees, nor is this, nor is this. So one of the laws that we can use is cosine law. Cosine law. So let's just say what these is: A, B, and C, and this is theta 1. So the cosine law says that C square equals A square plus B square minus 2AB cos theta 1. Now this formula here is just finding out the sides, given that we have the angle here. So we have two sides plus a given angle, and we're trying to find this side. If we have three sides given and we're trying to find the angle, well, and we're trying to find this angle in particular, we can say that, I guess, cos theta is equal to A square plus B square minus C square divided by 2AB. It's theta. So this is for finding the theta here given the three sides. So let's just do an example here of how we can sort of apply these. So in example number 1, let's just draw another triangle that's not 90 degrees, of course. And you can use this, you can use cosine in 90 degrees as well, but it's a lot more work. If you wanna learn how to do 90 degrees, I suggest you watch my previous video. So this is obviously not 90 degrees. We'll say that this is 110 degrees. And we have A, which is 7, 5, and we're trying to find C. So that's what we're trying to find. What is C? What is that length? Okay, well, we can use this one right here. We don't know C square, so we're just going to write C is equal to A. We know. Well, let's ACB. Okay. We know that A is 5 square plus 7 square minus 2 A and B, so 5 and 7 cos, and the angle, which is 110 degrees. Therefore, C squared is equal to 25 plus 49. And if you work all this out, you get plus 23.94. C squared therefore is equal to 98. So of course, to get rid of the square, you're going to square root. Whatever you do to this side, you have to do to this side. So C is equal to approximately 9.89 or 10. So that's how you do cosine law if you have two sides given and an angle, and you're trying to find its respective side. So what if you have three sides and you're trying to find the angle? Well, let's do that example as well. Whoops. Let's go back here. Okay. See, well, let's just use this number. Let's say 10 and then 5 and 7. We know that this should be around somewhere around 110. So let's just see if it is. So we're gonna say, remember, we're gonna use this. Oops. We're gonna use this equation now. So therefore, we're gonna say cos theta 1, I'm just going to call this theta 1, is equal to a square, which is 7 square. Let's see, a square, which is plus 5 square, minus c. How do I know this is c? Well, if we're trying to find this angle here, then the respective side is going to be negative. So if we were to find a, then its respective side would, the negative side would be 5. So we're going to say 7 squared plus 5 squared minus 10 squared divided by 2 times 7 times 5, which is equal to minus 26 over 70. Theta here, and then we have to go to the tangent, which is cos negative 1. So if you work this out, you get 111.8 degrees, which is fairly close to 110 degrees. So that's how you do cosine law when you have three sides given without and no angle. And this can also, remember this, that this here, or actually I should say this cosine here can also be applied for right angle triangles, but we're not going to do that because it's a lot more work, and cosine law is something that you want to avoid because it's a lot of work, and a lot of work means there's going to be errors. So that I guess that concludes my cosine law, and then the next one we're going to talk about is sine law. So now we're just going to talk a little bit about sine law. So sine law. Let's just draw a triangle first. Sort of like that. This is not 90 degrees. Let's just label our triangle A, C, B, small b, small c, and small a. So sine law states that the side A over the angle A is equal to side B over the angle B is equal to C over the angle C. So if we were to solve a triangle using the sine law, this is how it would be done. Let's just draw a triangle here. Not 90 degrees, of course. Sine law is used for that. Is angles for that. Those are not 90 degrees. So C, A, and B, small c, small a, and small b. So we're given 6 here, 12 here, and for this we're given 35 degrees. Okay, so how would we solve? And we're asked to solve the triangle. So solve B, solve the angle here, and solve for the angle here. Okay, so let's start by solving this angle here. So the C angle here. So if we use this formula over here, we would say that 12, which is A, and I'm going to use this angle, over sine 35 degrees is equal to, and I'm going to try to solve this, so I'm going to say we have the side for it, 6 over, we don't have the angle, so I'm going to say sine C. If I solve for this, I have C is equal to 6 over, and if you go 12 divided by sine 35, you get 20.9. And the sine then becomes the tangent, so -1. Therefore, the angle C is equal to 16.68. So I kind of drew my triangle wrong here. This is supposed to be 16.68. Obviously, this doesn't really look like 16.68. So now that we have solved this, let's solve for well, we can solve for the angle here, right? Because all all of the angles added up together should give me 180. So 16.68 plus 35 plus b is equal to 180. Therefore, the angle b, it's supposed to be capital V, the angle b is equal to 128 degrees, 128.32 degrees, decimal 32 degrees. So this is what this is equal to, 28.32 degrees. Okay, so now we found the three angles. We have two sides. We still have to find one more side. So let's just draw the new triangle. So it sort of looks something like this. This is 35. This is 16.68, and this angle here is 128.32. 35 is the opposite 12 here, 16, 6, and we don't know this, so we still have to find that. So we're going to use the same thing here. We're just going to say 12 over sine 35 degrees is equal to, now we don't have the side, and remember we write the sides at the top, so it's going to be b over, and we have the angle, we have this angle, which is sine 128.32. If you isolate for b is equal to 16.4. So this is 16.4. So that was another example. Oops. Undo. So that was another example of how we use the sine law to solve the um, entire triangle. Now, of course, sine law you can use for right angle triangles, but again, we won't because it's a lot more work. You know, if we had a right angle triangle, we could have done just Pythagoras, and if you look at my videos prior to this, you'll know that those Pythagoras and the relationship that we used is a lot easier. So there you have it.